Can you hear me okay?
Yep, I can hear you good.
Okay. How's school?
It's going good.
Good. I have to use a new drawing program here. They don't like Windows Journal anymore. It's going to be discontinued. So I have to use this thing called OneNote, which is a little different, but I'm trying it for one of the first times here. So I might be a little bit weak on it. So, do you have your textbook?
We're not using textbooks yet, apparently.
Ever?
Well, not. We're using them later in the semester, but we're just like reviewing right now, so they have like printed out like worksheet sets that they've given to us.
Okay.
They're giving to us.
Okay. When you do get a textbook, let me know, just so I can know if it's the same one that I have. Most algebra students,
Try and check one out early.
most algebra students from Chatfield use the same textbook that I have. So I would expect it to be the same.
If it's from Chatfield, I guarantee it's the same one.
Yeah, well, unless they've changed it, in the last year. At some point, they're going to change it. But for the last 7 years, they've used this Larson, Boswell, Knold, and Stiff Algebra 2 textbook.
All right.
So, what are they starting you out with?
We haven't done really much. It's just like reviewing systems of equations and stuff.
So what we covered last time.
Yep.
Which was systems of equations. Okay, well, let's go a little further than that, which is chapter 2 in the book, which is about graphing. Well, just hold on a moment. Can you graph that?
Yeah. So you would plot your y-intercept, which is 0, 3. And then plot points using the rise over run 5 over 1.
So I'd go up 5 and to the right 1.
Mm-hmm.
That would be a fairly steep slope. All right. Now, if you ever get stuck, in other words, let's say I said to you, how do you graph that? Well, one method that's always certain to work is what they call a t-table. Let's just talk about that for a moment. A t-table is where you plot a set of points. So when x is 0, what is y? When x is 1, what is y?
4.
When x is 2, what is y?
Squares 4, so 7.
Okay. Now let's plot those 3 points. We have 0, 3 there. We have 1, 4 right there. And we have 2, 7 right there. Do you know what this figure is called?
Oh, it's supposed to be a bell curve, right?
A parabola.
Parabola, sorry.
That's all right. In other words, because it's a quadratic, it's always a parabola. Now, it can be a parabola that looks like that, or it can be a parabola that looks like that. But it's one or the other.
All right.
Okay? And in this case, it turns up because of the sign that's in front of the x squared term. In other words, if it's a plus sign, it opens up. If it's a minus sign, it turns down. And if I were to say y equals x squared, it would look like that. In other words, when x was 0, y would be 0. But it would still be a parabola that turns up. If you remember your translations, the difference between that and that should be, they should be exactly the same, only this one should be shifted 3 units up.
Mm-hmm.
So this T-table method is not a good way to go. They're going to tell you about it, and they're going to have you do it, and that's fine. You should be able to do it. In other words, you can always plot any graph of any function by making a T-table and connecting the dots. In other words, maybe the T-table gives me dots like this, and I have to graph it like this. Okay? But you don't always know exactly how you have to connect the dots, but in other words, maybe I'm connecting the dots like this. In other words, it's not always one way to connect the dots. So using a T-table is not a very accurate method of graphing functions. Whereas using the parent function is a very accurate way. In other words, if we look at the parent function, which is y equal x squared, and we look at the function that we're asked to deal with, the only difference between those two is this plus 3, which means it's this curve vertically shifted 3 units up. So no change in the shape, but shifted up 3 units. All right, let me look through my book here. They did tell you that they were eventually you were going to get a book, or not?
Yeah.
Okay.
Yeah.
Just not yet, huh?
Not yet.
All right. I think we did this last time, but I'm looking in chapter 2, and give me the equation of that line that connects those 2 points. In other words, those 2 points are, there's 3 comma 5, there is 6 comma 15. What's the equation of that line? First of all, what's the general equation of a straight line?
Y equals mx plus b.
What's the next step?
Finding the slope, which is y2 minus y1 over x2 minus x1, which in this case would equal 10 over 3. So you'd have y equals 10 over 3x plus b. Plug in one of the points. In this case, you probably want to use 3, 5 since it's the lowest numbers.
Good.
So plug it in as 5 equals 10 over 3 times 3 plus b.
Okay.
And that last, then the 10 over 3 by 3, cancel the 3's, so you'd have 10 plus b equals 5.
Okay.
Subtract the 10, and you have negative 5 for b.
So what's the equation of that line?
Y equals 10 over 3x minus 5.
Good. Perfect. What's the slope of a line parallel to that line?
The line parallel, it's 10 over 3x.
10 over 3 only. In other words, this is the slope. Not 10 over 3x. It's 10 over 3. It's m. That's the slope. What's the slope of the line that is perpendicular to that? In other words, a line that's like that.
Y equals
Well,
3
no,
over
just what's
negative 3
the
over
slope?
10x.
What's the slope?
Negative 3 over 10x.
Just negative 3 over 10. Remember
Oh, okay.
that m is only the coefficient. It does not include the x. Okay? Alright. Let me look in my book here. What is most likely coming up for you? Probably by next Monday you're going to have material that you send me, which is the best way to do it.
Yep.
Hold on a moment. The slope of that line.
0.
What's the slope of that line? Vertical.
Yeah.
No?
There is no slope?
Well, no, it's undefined. But let's talk about that. There's a huge difference between undefined and 0. Let's talk about slopes. We go from a 0 slope to a slope of 1, because I have to go up 1 and over 1. And then as my slopes get bigger, that slope is, let's call it 4. That slope is 10. What do you suppose a vertical line is? If everything you see here is true. In other words, the slope of the 45-degree line is 1. The slope of the steeper line is 4. The slope of the steeper line still is 10. Well, what might be that slope right there?
12.
How about this one right here?
13.
Huh? Infinity
Infinity.
is a vertical line. In other words, notice notice what you have when you have a vertical line. If you're trying to figure out rise over run, well, the rise is any number you want. That's the rise right there, correct? We'll call it 2. What's the run? 0. So we have some number divided by 0. That's infinity. Now, in Algebra 2, they're reluctant to say the word infinity. They don't even like you to know the word, so they say undefined. When you get to higher math, they'll use the word infinity. But at this point, they tell you undefined. So undefined means infinity. And notice the difference between infinity and 0. Here's 0. Well, way out there is infinity. There's as much distance between 0 and infinity as there is any two numbers. So there is a huge difference between 0 and infinity. Just talk about that for a moment. I'm going to introduce you to something called limits, which won't get useful next year. But the limit of x over 2 as x approaches 0 is 0. The limit of 2 over x as x approaches 0 is infinity. Gigantic difference. And make sure you understand that. You can divide a number into 0 and get 0. But you cannot divide a number by 0. When you divide a number by 0, look what happens. In other words, if I take that bottom and I say 2 divided by 1, that's equal to 2. But now let's start making the bottom smaller. Equal to 20. Now we make the bottom smaller still. Equal to 200. Make the bottom smaller still. Can you see why the limit of 2 divided by x as x goes to 0 is infinity? Okay? As that denominator gets smaller and smaller, the result gets bigger and bigger. And that's the key. Talk about inequality. Just pretty much following chapter 2. Call this end graphic.
All right. I honestly haven't a clue how you graph that.
Well, let's talk about it. X is what?
Oh, this is a line graph. Okay, okay, now I get it. Okay, so subtract the 9 and x is less than or equal to 12.
Right? And because there's only one variable in that, then it has to be a single line graph. It's not an XY coordinate. You can't use an XY coordinate unless there's a Y. So because there's only one variable, we're going to use a line graph. I'll put the 0 mark on there, and the other significant number is 12. How do I graph x is less than or equal to 12?
So put a solid dot over the 12 and a line going to the left.
Okay. All right. Hold on. That's called apologize. I'm still getting used to this new program I'm going to have to use. That's the slope-intercept format. For example, y equals 2x plus 3. Okay? The reason it's called slope-intercept is because you have the slope and you have the y-intercept. The slope is 2, the y-intercept is 3. There's another format that's just as valid called point slope. What's that format?
Where you take one of the points of the equation and you...
Well, what's the general format?
Okay, so y minus y1 equals m times x minus x1.
Very good. For example, in other words, you might end up with something that looks like that. And furthermore, that's a valid answer. You don't need to simplify that. In other words, you don't always need to put answers in slope-intercept format. Point-slope format is a very valid format. For example, if I told you that the slope is 3 and a point on the line is 4 comma 5, give me the equation of that line, and the easiest one to do is point slope format. Because you can do it in one step. What's the point slope format of that line?
The point slope format would be y minus 5 equals 3 times x minus 4.
Perfect. And that's a perfectly good answer if they didn't specify anything more. Now, if your teacher said, give me the answer in slope-intercept format, what would it be?
You'd have to figure it out by putting it into slope-intercepts as y. Well, you'd have the y equals 3x plus b, so you can just plug in the point that you already have it as.
Do it one step at a time. So what's y minus 5 equal to? Three x
Plus 5.
no, multiply the 3 times the minus 4. Let's do it one step at a time. So it's minus
Okay,
12.
12.
Now move the 5 over. What do you have?
Y equals 3x minus 7.
Yeah. So that's the same equation as that. It's just in slope-intercept format instead of point-slope. So it really all depends on what they ask for. Notice that point slope I was able to do in one step. To get it into slope intercept, I had to do 2 more steps. I had to do that one and that one. And then finally I had it into y equals mx plus b format. But those are the 2 most important formats in algebra, are slope intercept, which is y equal mx plus b, and point slope, which is y minus y1 equals m minus x minus x1. And you should be able to work in either format. So, we give you 2 points. The equation of this line in point slope format.
Okay, y minus 3 equals m times x minus 2.
What should you have done first?
Slope. Dang it. Okay.
Always. Let's go back and figure out slope. Slope is always the most important thing. All the way up to calculus, in fact, probably higher math. Slope is everything. So what's slope?
Y2 minus y1 over
What
x2
the
minus
numbers
x.
are. Tell me what the numbers are.
Negative 4 minus 3 over negative 1 minus 2.
Which is?
We have negative 7 over negative 3.
Which is?
7 over 3.
Now, what's the point slope format for these 2 lines? Remember that any 2 points can only define a line. They're not 2 lines or 3 lines, but 1 line and 1 line only. So whenever you have 2 points, you have a line. So what's the equation of the line in point slope format?
So you could have y minus 3 equals 7 over 3 times x minus 2.
Perfect. That's the answer. What is it in slope intercept format?
Slope intercept.
Yeah. What's the next line?
So, all right, so distribute the 7/3 to
Good.
the x minus
Glad I
2.
didn't fool you by my... So we have at y minus 3 equals what?
7/3 x minus whatever 7/3.
Well, just do it. What's 7/3 times minus 2?
14/3.
Next step?
Add the 3.
The final equation. How do you do that? In other words, you've got most of it. You just have to combine the numbers. What's minus 14/3 plus 3?
That'd be negative 4 and 2/3.
Don't do it that way. Find the common denominator. You never ever want to do it that way, the way you did it. How many thirds is 3?
9.
That's the way you want to do it. You want to find a common denominator. So that becomes 9/3. Now what's the answer?
Y equals 7/3 x minus 5/3.
You got it. That's the same equation in slope-intercept format.
All right.
Now, if they would have asked, if they didn't specify what format they wanted it, then I would have left it in that format. It's the easiest one. If they specified that they wanted it in slope-intercept format, then you got to go that route. And you can see that it's a lot harder to come up with slope-intercept format with these 2 points, just because it involves fractions and you have to add a fraction to a whole number. But don't forget how to do your algebra. In other words, when you're dealing with a fraction and a whole number, the answer.
So you can find a common denominator, so that'd be 6/3, so you'd end up with 1/3.
That's big. You'd be amazed at how many people that trips up. They forget that just because there's a whole number there, you still have to find a common denominator. That's 2 over 1. Okay, so the common denominator is 3. But for some reason, when you throw that integer in there, people just completely forget what to do. So, good place to stop. Hopefully next week you'll have a book or at least material. If all the stuff they're giving you is online, that works also. We can still handle it. But I'd rather stay on what you're doing in class than what I think you might be doing. You understand?
Yeah.
Right now I'm working off my Algebra 2 textbook, so I'm assuming that that's the direction you're going, but I can't be certain. They can always change it up on me. So the sooner you can bring information to the table, the better. Although I certainly have plenty of material to bring. Cole, have a good week. I'll talk to you next week.
All right.